Welcome to my talk on Doctrine without E, to use or to not to us. The title is a little bit cut off, but I checked this is the only slide which is cut off. If you see anything, just mention it and I will try to find or explain it. So this talk is about Doctrine, and the title is sort of black and white, use Doctrine or not use Doctrine, but the talk is actually not about the black and white decision here. I will try to explain a little bit what the limitations of Doctrine are and why we actually have limitations at all, and try to give some ways of working around them if necessary in your code, for example. I'm Benjamin, and I'm partly responsible for Doctrine since version 2.0 alpha 1 or something. Most of the code writing these days have been passed on to Marco, for example, who's sitting here in the first row, and a bunch of other contributors. So at the moment we are sort of eight contributors who work on the database abstraction layer and the ORM around, and we are doing different tasks and working on that. So the first thing I want to do is to get like a little feeling from you guys while you're sitting here. Who has used Doctrine and really wanted to throw it out the window, smash your computer or whatever, got very angry at using Doctrine? Yeah, that's a very great number. Yeah, good. Yeah, super. So who has either who has had his moments loving Doctrine and said, like, this is amazing how much this is doing for me? Yes. So that is also a high number. It's great. I gave this is the third time I gave this talk, and usually people raise their hands on both questions. So it's really a love-hate relationship that we have with object relational mappers, and in this case, Doctrine. So Martin Fowler describes this problem of ORMs in a blog post, and he calls it ORM hate. So he says whenever he goes to some conference, like, all the speakers will always rant about ORMs, and the people sitting in the rows, they will also like rant back and, oh, ORMs, they are really bad, and all the problems that people are having with ORMs. And his important point he was giving in this blog post was that the frustration with ORMs is mostly about having the wrong expectations about what the tools can actually do and where they can help us. And this is what this talk is about. Writing an ORM is a very, very complicated thing, and with Doctrine we have made it very difficult for us because we want to write a very good ORM. And mapping objects to a relational database and back from the relational database to objects is a very, very hard task because both worlds are actually incompatible to each other. On the surface, they look very similar, and you might think, okay, it shouldn't be too complicated to map a table to an object, foreign keys sort of map to references, and you find a lot of similarities. But if you look at the little small details, then you see that it's actually very different. And this is something that we want to abstract or to allow you to use that in the ORM. And it's a complicated task. One thing that we have to look at with ORMs is a concept that Vilfredo Pareto described. Not in the concept of ORMs, he described it in a more generic way. So Vilfredo Pareto was an economist, and he found out while looking at the distribution of land in countries that essentially in most of the industrial nations at this point, so in Italy, in Germany, and the UK, he found that 20% of the people owned 80% of the land, and 80% of the people owned just 20% of the land. This is applicable to many, many other things, and land at that point was sort of, yeah, if you had land, you were rich. So if we talk about the distribution of wealth today, then it's also the case that a few number of people have very high number of wealth, and a high number of people have very few amounts of wealth. And this concept Pareto discovered. And in a business book, I think 20 or 30 years ago, this was sort of formalized to describe something called the 80-20 rule. The 80-20 rule says that essentially everything has a relationship of 80% to 20% something. For example, if we think about IT projects, then usually we can implement 80% of the features of a project in 20% of the time. For example, using Symfony and Doctrine and all the features they offer. So after some months, we go to the product manager and we say, yeah, we are 80% done. But the problem with this is that this was the easy part. We only took 20% of the time getting there. So in reverse, it takes about 80% of the time to implement the rest of the 20% of the project. And this is something I guess everybody of you has seen as his projects. Like if you talk to your boss and say, yeah, it's 90% done or it's 95% done, this usually means that the hard things are still coming and it takes a lot of time to get to 100%. So this is something we can apply to libraries as well. So Doctrine is essentially providing you with 80% of the features that we can easily do, and we can easily provide to you in a very generic way. So we as library developers, we don't know what you want to do with that. And we have to concentrate on building a library that is very well versed for most of the use cases, but we cannot support all the use cases. And I think in object relational mappers, this is usually the first library where you'll find problems and you need to start working around it. So Symfony, for example, is a framework for the web, and we use it for the web. And by definition, it used some kind of niche by doing HTTP requests inside PHP and can focus on this quite well. So Symfony is probably not the first point where you start having troubles in your project when you start to work around things. Doctrine is usually the library where you have the first troubles implementing something. And this is because I'm not actually sure we are able to provide 80% of the features for you. It's very, very hard to write an ORM which is so versed that you can use it in very many of the use cases. So let's say we build Doctrine for the 80% use case and we try to add something on top, but we are not sure if it's really usable. However, 20% of the features that you might need in your project are not very well doable with Doctrine. And some of the features we could add additional things into Doctrine to make it more usable, more easy, and maybe we are lacking a little bit of time doing this sometimes. However, some of the decisions are actually made by us on purpose. So we are doing some stuff on purpose because pushing farther than the 80% too much would make everything else worse, slower, or harder to use. So we need to stop at some point because we are a generic library and we cannot support everything that you want to do. So this means in turn, 80% of your use cases on average can be done with Doctrine and 20% cannot be done in a good way. So you need to adjust for this or have this in mind. The first and the most important thing that I want you to take away from this talk is the decision for using Doctrine or any other ORM is never an all-in decision. You're not going and say, oh yeah, let's go all in on using Doctrine, and then every problem you're seeing in your project has to be solved with the ORM. This is not what we want you when you use Doctrine. We want you to find the cases where it's not applicable too well and then use maybe some of the features of Doctrine or work around a little bit. It's not a black and white, don't use Doctrine or use Doctrine. It is a talk about you can use Doctrine for quite a lot of stuff, and it's really awesome at that. But there's also stuff where you cannot use it and where you shouldn't use it, and maybe it's better to work around it from the beginning. So what is Doctrine good at? And this is actually, like, for many of you that might be interested in domain-driven design and all this kind of domain modeling and all this kind of stuff, might be a very boring or sad answer. But Doctrine is actually super good at CRUD applications. So if you combine Doctrine with Symfony forms and validator and all this kind of stuff, and your logic is not so complex based on forms, then this is the main or the best use case you can use Doctrine for. It's extremely flexible with that. And Bernard made sure that Doctrine is actually very, very usable with the form and the validator component, so it's super powerful. If you're going into the direction of some domain-driven design modeling, then Doctrine is very good at some kind of domain-driven design light. So Doctrine has some problems with, it shows you the internals of the database. At some point, for example, the inverse side, owning side problem. What is the inverse side of an association? What is the owning side? And there are some things during the usage of Doctrine where you clearly see that this is mapped to a relational database table. So you can use Doctrine to abstract a lot of stuff from the database and have a sort of an abstraction layer of the database, but you can never really hide everything. It's not completely hidden. You see that there must be a database underneath because you're doing some weird stuff that is necessary to make it work on a relational database. Doctrine is a little harder to use if you want to push further and really decouple everything from the database much and much more. And if you see a blog post by Will Duran or by Michael Novak, they have several blog posts about trying to do that. And you see it's actually very hard to do. There are lots of steps involved in doing this. And you have to write a lot of glue code and be careful about stuff to reach this level of abstraction. Oh, that was the wrong direction. What is Doctrine actually very bad at? So Doctrine is very bad at scenarios where you have entities that are very different when you write them into the database and then when you read them out. So if the representation that you need for displaying something is for writing something, then it's difficult to use Doctrine because you're starting to write very complex queries with Doctrine, and you're writing a lot of data that is probably not used from your queries, and then the hydration gets slow, displaying of data gets slow, or the other way around. If you optimize your model for the reads, then it might be very difficult to actually write it to the database because you have to have so many entities or connect them in a weird way to actually save them. So if your model is almost the same for a read or a write, then Doctrine is very good. If it starts to differentiate too much, then it's getting harder to use. The next use case where Doctrine is not very good is in extremely high write throughput. Doctrine is fast enough for writes, but not if you have tons of thousands of writes and they're getting in a very, very, very fast per second, per minute frequency. The problem here is that the saving inside the unit of work is quite complex, quite expensive, and it's optimized for the use case where you're saving just a little bit of data. Just one entity here, 10 entities there, but it's going to get very, very slow and annoying if you do lots of entities all the time. It takes a lot of CPU cycles that are not necessary if you write this in another way. And the last thing, analytics, statistics, and reporting are very bad with Doctrine. So this is something that you cannot do with the ORM in a very well way. So as a result, Doctrine and domain-driven design, we sort of have this Doctrine is sort of known as a library where you can do domain-driven design with, but you should be a little bit careful. It's only possible to some degree. And the most important thing is that you can never fully abstract the database. The database is always there, and as a user of Doctrine, you cannot say we have an abstraction layer that is abstracting this database from us. We can stop thinking about the database. You always have to think about the database when you use Doctrine. You should know what's happening, and you should try to think about what is actually happening in the database, what statements get executed. Am I doing this correctly, or will the sysadmin, if he sees that, will he cross his hands over his head? So what are the sort of 80% building blocks that you can use in Doctrine? So I said before, Doctrine is super for CRUD, so everything related to CRUD, simple find methods, delete, insert, the flush operation, all this is super stable and super good to use, and you shouldn't worry about using any of this functionality. Same with associations. Most of the stuff in associations is actually totally safe to use. The only thing I would not recommend doing is bidirectional one-to-one, and using features like cascade and orphan removal, all this advanced stuff, too much, because it can lead to interesting effects that you might not understand or might feel weird about. So I'm usually just using the most basic association features. Lazy loading is one of the central features of Doctrine, and we made sure it's very powerful and very usable. The repositories, the Doctrine query language, and the native queries, all this kind of stuff is very usable and safe to use. And if you're just working with this set of features, then you shouldn't have many problems working with your application if you work around some of the 20% that you have. What are the things you have to look out for? So if you're trying to use some of the more advanced features, then we are trying to give you the possibility to push a little bit further with the ORM. So instead of going back to writing SQL manually at some point, we try to implement at least some features to do more advanced use cases. However, depending on how you use them, in this case, you are at risk of unsolvable edge cases. For example, in the case of the Paginator component, we have tons of edge cases that are not solvable. And depending on which underlying database you're using, for example, if you use SQL Server, just don't use the Paginator in many cases. It's really difficult for us to do this with the same power that MySQL does. Some of the more advanced features introduce high coupling. So you have suddenly high coupling between Doctrine and your code. So you reduce the testability. This applies, for example, to events. When you use events, you put logic somewhere else where Doctrine puts it, and it makes it very hard to not test this outside an integration test. So you suddenly need integration tests for everything. And it's a bit difficult. And there are other features that couple your code a lot against Doctrine, which is not necessary in all use cases. And the last thing is that you might get performance problems. So Doctrine, in general, is not a very fast library. ORMs, in general, are not fast because the mapping problem is very complex. If you are trying to make the mapping, the direction between like the objects and the tables more difficult than Doctrine wants it to be. So if you're doing complex stuff and map very complex things, then this can easily lead to problems inside Doctrine that make it even slower or lead to other problems that are difficult to solve. So let me show four dedicated blocks that I think are critical, or no, not critical, but you have to be careful using them. The first one I want to talk about is inheritance. So object-oriented languages have inheritance, and inheritance allows us to have a hierarchy of objects with different properties and all this kind of stuff. And we implemented this in Doctrine, that you can have an inheritance hierarchy, and you can save this in a database. The problem is, relational databases, they don't know about inheritance at all. They don't know what this concept is. So the mapping process between inheritance objects and inheritance in the database is complex, way more complex than objects that don't have inheritance. So what are the problems that we have in implementing this? See this example. We have an order item, and it has an association to a class product. And we have a hierarchy of products. So we have different kinds of products. Let's say a digital product and a physical product. And we have an inheritance hierarchy in Doctrine. One problem here is that for the object relational mapper, this is for the objects to build it this way, it's super simple. But for the object relational mapper to write this into the database, we have a big problem. The problem is that this case completely disables the possibility to do lazy loading. So using inheritance in an association doesn't allow us to use lazy loading anymore. This object has to be loaded. The reason for this is very simple. If we fetch all the data from the order item table, it will show us a foreign key. The foreign key has a number, let's say 17. And the problem is, when we want to create a proxy object for this case, it is not enough to know just the number 17. We also need to know the type. And to know the type, Doctrine has to go to the other table, fetch the data, and look at the type. And because we're doing this query anyways, we're just saying, OK, then let's fetch all the data. It's better to fetch it only once than to do 2 queries. So Doctrine loads it into memory. We've been thinking about fixing this, but the problem here is it's very hard to fix it because Doctrine needs to create the proxy object, put it into the identity map. It has to be known there. So the type has to be known all the time. So we cannot really get rid of this extra query. And if you're using inheritance, then you're losing a lot of lazy loading functionality in Doctrine. And this could lead to over-querying, so having too much queries all the time. The next problem in inheritance is using join table inheritance makes your application slower without you realizing this. Join table inheritance means you have one entity hierarchy mapped to multiple tables. And depending on how you query this, this will lead to a lot of left joins, inner joins, all kind of stuff. But in the code, you don't see this. You just do find for this entity. And then you maybe do a DQL query where you join the inherited entity with even more entities. And then you get lots of joins. And usually it depends on the database. In the number of joins, the database usually get a little bit slower. And this makes it a little bit difficult to work with, especially with left joins. They cannot be optimized so well in databases. So if you need inheritance, you can do something else. You can say, OK, if I just need arbitrary properties, then this is something that is not a relational problem. It's a NoSQL problem. So if you say, OK, but I don't want to use NoSQL, I want to use the relational database, then OK, that's fine. Doctrine provides some types that allow you to do NoSQL-ish stuff. For example, JSON array, since 2.3 or 2.4, you can save an array of the hash map of stuff as an array in the database. And if you're using PostgreSQL, then you can even extend Doctrine to allow queries on the JSON objects because PostgreSQL has support for JSON. Marco said to this, if you don't want to use JSON array, you want to use some object, then you can use the functionality from Doctrine to introduce custom types. So you don't need to use a hash map. You can even use an object there and map it to JSON back. So that is very powerful. The next thing I want to talk about in Doctrine, which is a little bit wonky, are events. Events are used for quite a lot of extensions, and many of you are probably using the getMo extension or other extensions to put additional functionality into Doctrine. The problem with this is Doctrine is already a big abstraction layer. It's already hiding a lot. when we are using something like get more extensions, then in this case where we fetch a product from the database, we don't know like if this title column is translated, like how does it do additional queries, and it might do a lot of additional queries that are very hard to understand why they happen, and it introduces complexity on the on the inside of Doctrine that you cannot really see. So it hides a lot of stuff, a lot of complexity that might be very slow, or might get slower every time you add more stuff to the database. The problem with events is also that they run on every flush, even if you don't need them. So they run all the time, and often you must detect that the listener doesn't need to run now and we stop doing anything. However, this adds CPU cycles all the time during every flush. The most important problem with events is they don't run in context. So the Doctrine events say something like, this entity was updated. However, with events, the most important information is not that something was updated, but the why was something updated. So if you send an email when registering a user inside a Doctrine event, then you don't know if the user was created through a batch job or through the user interface. And sometimes there's a difference in this. In the one case, there has to be a mail. In the other one, there doesn't have to be a mail. Also, the last point, some extensions on top of events are very inefficient. Some translations or versionable stuff I've been seeing is very, very slow, and you start with it in development and it looks fine, but once you go into production data, it gets super, super slow. So the fix for this is actually make it more explicit. Events are allowing you to do a lot of magic, and sometimes this works out quite well and is fine, but sometimes it's just hiding a lot of behavior. Using the generic events, it doesn't have context, it slows everything down, it's not very specific. So instead, you can use something like domain events to make very explicit what happened, or you can build the logic directly into your services. For example, for file uploading, if you're uploading files for specific entities, then this happens in just one place. You don't need a listener that runs in every flush operation, because you know the one place where the file upload happens is in the file upload form. It doesn't need to be decoupled, really, because this belongs together. The third point that is hard in Doctrine, and this is one of the points where Doctrine is really, really bad at, is batch processing. So the bigger the unit of work gets, which means the number of entities that are in memory in the single request, the slower everything gets in Doctrine, especially the flush operation. So a good number of entities in the identity map for a fast flush operation is about 100, depending on how many properties there are in the entities. But after that, it gets really slow. And most of the batch processing code in the documentation has a lot of, you have to call clear function after the flush every 10 times. You have to do quite weird stuff to clear the memory. And in many commands, I see that do batch importing with Doctrine entities. There's also a lot of memory get peak usage so that you can find the correct level of how many you can do. And still, all this code is very slow, so the flush operation is very slow. I've seen a lot of tweets about, like, oh, we removed Doctrine from this import command, and it's not taking 2 hours anymore, it's just taking 2 minutes or something. So this is really true. Like, Doctrine is really, really bad at this. And one solution for this is, if we don't want to throw Doctrine away completely, we can try to find an additional model and maybe reuse some of the code from Doctrine for this. So let's say high throughput import commands, for example, they're not about full updates. They are usually about changing something. So let's try and model the change instead of modeling the entity itself. The entity is something that is this is the entity. It has these properties. However, in most cases, you have a stream of changes, like in big import commands, you have this big stream of changes, apply the changes. So let's try modeling the changes a little bit. We introduce some objects that represent change. And Then we create these objects. This is just very simple. You can add some getters and setters, validation if you want. And then we aggregate all the changes. We reuse our Doctrine repository and apply all the changes. So how do we reuse some of the business logic that we integrated into our entities? That's easy. So let's introduce some value objects for price and availability, for example. So we can have some of our logic on value objects and reuse the value objects here in this code, reuse some of the business logic, and then have another concept of saving the values into the database, a change, instead of an entity. And this way, we work around Doctrine's problems with batch commands. We reuse some of our code. We have to introduce some duplication. That is the problem. However, we reuse some of our code. And we make it much, much faster. We still have an object-oriented API. We are not working completely just with raw SQL. The fourth and last point I want to touch is DQL fetch joins on pagination. So Doctrine hydration and Doctrine, the possibility to fetch graphs of objects in a single query is super powerful. And if you've seen and used this, it's quite amazing. And I'm still always scared looking at the code, how we wrote that, like that is actually possible doing something so complex. And the hydration code is the most complex code in the ORM. However, by overusing this, we are introducing a lot of problems with performance and also edge cases that are not really solvable. So I said before, if the read model is very different from the write model, then it's not a good idea to use the entities for the read scenario. So this example, it's a very, very common example. For example, if you use the Sonata admin bundle, like you would say this huge list and it would show a lot of relations, a super nice list view of products, addresses of the customers, and then all the items that he had ordered in this product. So this is a very common use case. However, in Doctrine, building this kind of stuff is actually a little bit scary. So you have a select query. You might need a bunch of fetch joins of additional data to run an efficient query. And then, because you have associations in those fetch joins, you have to use Doctrine's paginator component that modifies the DQL a little bit internally, does some magic to efficiently grab all the objects and fetch them correctly from the database. And all of this, in the end, is super slow. If you look at this kind of query in the profiler, any kind of profiler, Blackfire, for example, XHprof, XDebug, the slow code here is actually PHP in the hydration code. The SQL query for this is usually super fast. If you have indexes, it might take just 10 milliseconds, 5 or something like this. But the objects itself, like hydrating this kind of stuff, can take 100, 200 milliseconds of performance. And this is only necessary to display data. So it's a super simple use case. You don't actually need the logic on the objects. It's just displaying something. So the pagination and using DQLs and very complex scenario, applies a lot of magic to make it work, and all that magic is slow. And there are also edge cases depending on the database. Sometimes you invest a lot of time to make it work, but all this time investment could be much better used by doing it a little bit different and a little bit simpler and much, much faster. So the alternative I would suggest is, if the read and write models are different, then just make it very explicit. Introduce something called view models. So instead of going from how does the database look like, go to how does the view look like? What are the items that need to be displayed? Then build a model that looks like the view that you need in the view, and then look like how do I need to write the queries to actually construct this new model that I just created for the read. And this can be done quite simply. In our case, for example, order list entry. We put all the properties on there that we need for every list item that we have here. And then we go back to the Doctrine repository. We create a custom method on the repository that doesn't return entities, but it returns those view models. And sometimes here, we can reuse criteria objects that we are using to build queries here. So we can reuse some of the logic we have here. And instead of returning the order item entities with all their associations and the slowness that comes from using a big complex fetch join, we're using very efficient SQL. And especially with complex queries, you sometimes need to execute multiple of them to get a better result instead of executing just a single very, very big one. It's sometimes more efficient to do the first query and then gather all the IDs for some related entity and then do one second big where in query to fetch more data to show. And this is something that we know how to do manually when writing SQL, but it's very hard to do that with Doctrine. And then leads to a little bit of slowness. So what else? So if we sort of accepted that we cannot solve all the use cases with Doctrine, the question is how to go about this. In Symfony, there's always a service for the raw database connection of Doctrine. Use that. You can use it to write queries, generate results that are not similar to the entity results. Something different is much easier to do. It's only important to hide this in some repository that is related to the tables that you're writing. For example, in the case before, if we write a view model query for order items, then it might make sense to put this query into the order item repository as well. The second thing is, on the entity manager, you can call get connection. So inside the repository, you can always call get entity manager, get connection, and then write just raw SQL, if that's faster for your use cases. The Doctrine database abstraction layer API are actually super easy to use. There are methods for updating, deleting, and inserting rows that just take arrays, key value pairs of put into this table this data, and you're done. It's very, very simple to use. In this case, we have a call for the update of the products table. We are changing the price of a product with the ID from the change object. And it's actually very easy to write this kind of code. And for batch operations, which this is the target code, it's, you can get around a lot of the problems that you have using the ORM for batch operations. The same for listing stuff. In the entity repository, you call get entity manager, get connection. And then Doctrine has a query builder for SQL queries as well. So if you're building complex SQL, there's a query builder doing SQL queries, not Doctrine queries. So it's not writing SQL manually in big strings. You can also use a query builder. One thing that I hope to convey is that an ORM is still very good for many use cases, and Doctrine is, I think, very powerful. You should not try to write your own ORM. So we've invested a lot of time in writing ORMs, and it's really painful. And the problem with writing an ORM is if you read a pattern book about writing an ORM, it looks so simple. And like giving the Pareto principle, it is simple to implement the first 80% of all the features. And you're getting very, very quickly very nice results. But once you start looking at edge cases, it becomes really problematic. And then at those edge cases, you normally have huge performance problems that you need to solve. Okay. Another solution could obviously be NoSQL, so you could use something different than a relational database. And in many projects, it makes sense to mix different databases. So let's say in many projects, we have MySQL as the primary data store and something like Solr or Elasticsearch as a secondary store. So we are sort of replicating the data into something that is better for searching the data. And we are getting view models out of something like Elasticsearch or Solr. Or in some cases where we have 80% of the project implemented with relational databases, super simple to do, and then the rest is done with MongoDB, CouchDB, Cassandra, whatever you need. So mixing databases can help with this problem. The conclusion you should take from this talk is avoid complex mapping as much as possible. And this is something where Doctrine is going away from being perfectly suited for domain-driven design. It should always be the case that the objects are as nearly equal to the tables that get generated out of this. Once you start deviating by this too much, it introduces a lot of complexity inside the unit of work, inside Doctrine, maybe performance problems. So this is where you can't really go and let's design all our objects up front and then we look at the database later. It sort of always has to be, okay, we want to use objects and let's do it this way, but let's not forget that this will be saved in the database. So let's make sure as soon as possible that we don't screw this up. And the second thing is always think about the database, even if you start modeling from the objects. So you're writing tests for your domain model and still always think about what will this actually do in the database. Thank you very much for it. Yeah. I still think I have time for 1 or 2 questions or something like this. So, any questions? No, actually not. Oh, though, 1 question.
It's not about your talk, but as you are here, what are the plans for the future of Doctrine?
Okay, so the plans for the future of Doctrine. Marco and Guilherme have met at True North PHP and talked about the plans for Doctrine, Doctrine 3 in particular. And currently, we are just thinking about a lot of stuff, what we want to do. Personally, I think Doctrine should be as backwards compatible as possible. I'm sort of the guy in the room trying to avoid Marco and Guilherme breaking all this stuff. And they are sort of looking at it from a perspective like, what could we do? So currently, we are sort of trying to work out like what will be the path to Doctrine 3. But in general, yeah, the way, I mean, you probably see this, like the velocity of changes on Doctrine is not so fast anymore like it was before. So we are sort of a very slow project at the moment. We are working on stuff, Marco especially, and Diki and Zeroed In. They work on database abstraction and ORM, push out bug fixes. But in general, yeah, it's a little bit slower at the moment. So yeah, I couldn't know, like there's nothing big coming in the next months or releases or something. In general, I think the library is super stable unless you use some of the more wonky features or dangerous things or deviate from our primary use cases. If you're using it conservatively, then it's totally fine. Most of the bugs in the core are all fixed. It's very stable to use. Okay, other questions? There's a question in the back on the right. Yeah.
Is it the role of Doctrine to handle multi-masters connections?
To handle what?
To handle multi-master connection, for example, for a Galera cluster or master-slave connection? Handle things like exceptions thrown by one of the master server? Is that the role of any ORMs or not?
I think both master-slave and, for example, something like implementing something like sharding is very hard in a generic ORM. So if you, I think Doctrine works with master-slave, but you have to be very careful there. At least for MySQL it works. But I think like master-slave and something like sharding are already part of the 20% use cases in parts where it's very hard for us to build a very good solution there. So for master-slave, it sort of works, but you have to be careful, especially if you start reading and then writing from the different databases. But something like sharding, for example, which is even more advanced than master-slave, this is not supported at all by Doctrine. So it's a little bit, you have to be careful using master-slave.
And master-master is about 5% of the use case?
Master-master is something you should never do with a relational database. So MySQL master is a pain to use, I think. Okay. Master is something you do in NoSQL databases, like MongoDB does master, sort of CouchDB, replication, Cassandra. If you have this kind of databases, they work better with multiple masters. Okay, thank you very much again. And yeah, have fun at the conference.